Hello everyone, welcome to Techie Talks AI. This is Abhijit here, and today we are building an awesome app to access Agno agents via API. Agno is a lightweight and very powerful framework for multi-modal AI agents. And if you are not familiar with Agno, my colleague Sri created a lot of videos on the Agno agent. Those are very useful, so please go through the channel videos so that you will be able to get a good idea of those Agno agents and also examples on how you can use Agno agents in different ways. So in those examples, what Sri did is he showed us how we'll be able to make use of the Agno library to create intelligent AI agents which will be able to perform different operations. So he showed us how we can add different features like structured output, then how to add tools, etc. Today I'll be showing you a way using which you will be able to access your Agno library or your Agno agent via API call. And why is this important? When you are creating an AI chatbot or when you are creating an AI application, what you want is you want to run your agent as a service in the background and to be able to access that particular agent to perform different operation as and when it is required. So that is where we'll be implementing Agno library as an API in the backend, and we'll be creating a Streamlit frontend application using which we'll be accessing that backend via API. So we'll use Streamlit to create a dashboard where you will be able to send your queries or requests, and it will communicate with the backend Agno agent, which will generate the response and it will be streamed back to the front end. So that is what we are going to see today. And along with this, as a bonus, I also added the logging feature. So what happens is when you perform API calls, you need to have a way to keep track of those calls. And that is where logging is important. So in this example, I'll show you a very simple and basic way of logging using a log file. So each and every backend call will be logged along with the query and the response. And I also created a log viewer application using which we'll be able to see the logs generated. We'll be able to filter the logs. We'll be able to go through the logs. So essentially we'll be able to visualize the log, which will be very useful in the long run. So whether you are a developer or an AI enthusiast, this tutorial is for you. And before we proceed, if you haven't already, please do like, share and subscribe this channel so that you will be able to get access to recent 20 tutorials and other technology videos. Okay, now let me give you a very brief introduction of Agno. So if you watch Sri's videos, then you will know that it is an autonomous program using language models to perform different tasks. Agno agents are super cool. They are AI agents that can handle tasks like searching the web or analyzing financial data, etc. But till this point, we have been accessing this Agno library programmatically using the Agno Python library. Today, we are going to see how we'll be able to convert this library into a backend application and to be able to access this library via an API call. But managing these API calls can be tricky without a proper tool. That is why we are also building a Streamlit app to send requests to the Agno agents, log every interaction, and even visualize trends like request frequency or response time. Now let's set up the environment. So if you want to do this, you will need to have some knowledge about Python, Docker, then API call, etc. But I'll explain what it is that you need to understand as and when we reach that particular point. You will be able to access all the codes that I am using via the Git repo link that I add in the description below. So please use that so that you will be able to follow along. So let's start. Let's look at the code. So here, once you clone your repository, you will be able to see this Agno-API folder. So this is the folder which will be used for this particular application. And as you can see, this is the directory structure. So we have a backend directory which will contain the files that are required for our backend application, which is our Agno agent that will be running as the backend. Next, we also have the frontend directory which will contain files related to our frontend application, which will be accessing the backend via API calls. And this frontend application will be implementing using Streamlit. And then we also have the log viewer folder. So this folder contains files that are related to our log viewer application. So this log viewer is used to view the logs that are generated during the API calls that the frontend makes to the backend, and we will be able to work with it. That is what the use of this log viewer application. And apart from that, we also have the logs folder. So this is the folder where the application will store the logs as log files. Then apart from this, we also have the docker compose.yaml file. So this is the file that we will be using to set up this application in a dockerized environment. And you will also see the nodes.txt. So this will contain instructions on what are the commands that you need to execute to perform the operation. So this is the directory structure for this particular application. Now let's see each and every item one by one. So this is the directory structure. So first let's see the backend application. If you open the backend folder, you will be able to see three files. One is the Docker file, then main.py, and finally requirements.txt file. So let's look at this main.py file first and see what it contains. So this is the main.py. So this is our Python backend application. This is our main.py. So as you can see, first we are starting with the libraries that are required for this backend to work. So it will include the Agno libraries, it will include the FastAPI libraries. So this FastAPI is a Python library which is used for managing API calls. So we'll be using that Python library in our backend application. And we are also importing libraries that are required for logging, etc. Next, we are setting up some variables to be used as part of our API call in order to secure the API call with API key. First, we are setting an API key. So this API key we are getting from an environment variable called API_key. So this environment variable will be setting within our docker compose.yaml file, so that when we run the docker compose, at that time itself we will be able to specify the API key that we want the application to use. Next, we are setting the API key header, which we will also be using in order to authenticate the API calls. Next comes the logging part. As you can see here, this will perform the logging operation. So it will first create a directory called logs. If it is not there, in our case the logs directory is already there, so it will not create. And what it will do is, inside this logs folder, it will create one API_calls.log. So this will be our log file. And all the logs that are generated whenever there is an API call happening, it will be done within this particular log file. Next, we have the validation, the API key validation. So this function, which is get API key, will validate the API key. So what it will do is, it will get the header from the API call, and from that header it will extract the API, and that API key it will compare with the API key variable that we have configured earlier from the environment variable. And if it is not matching, then it will raise one HTTP 401 unauthorized error, and it will be denoting the invalid API key. And if it is matching, then it will just return the API key. So if it returns the API key, then that means the API call is a valid call. It is an authorized call. Next comes the agent part. So this is the part that I have used directly from what Sri have showed us. So this is where the Agno agent is initialized. Now I made one change in this one. So in the previous video I showed you how you will be able to create a local GPT on your own from scratch, how you will be able to use Ollama models for that. But here what I'm doing is I have installed Ollama within my local machine, and I am accessing that particular models within Ollama as the model for my Agno agent. So this is how you will be able to do that. So here what it will do is it will be accessing the model called Llama 3.2, that is the model name, and it will be using the host. See this, using the Docker internal host, it will be able to access the Ollama that is running within the same machine. This means that we have Ollama and Docker running on the same machine, and this is how you will be able to make sure that your Docker containers can get access to Ollama running on the same host machine. Okay, now this is the instruction for this particular agent. So this is a news reporter agent that will be generating news based on our query. Here we are specifying the tools that we want it to use. So it will be making use of the DuckDuckGo web search tool. And if you want to have any tool calls visible, and if you want the output to be in Markdown, you will be able to enable this option. So this is our Agno agent. So till this point we have been using this agent programmatically within our Python itself, but now we'll be seeing how we'll be able to expose it as an API. Now this is the API endpoint that we are creating. This is the FastAPI endpoint that we are creating to expose our agent as an API to our front. Here we are specifying the endpoint. So this endpoint will be /news. So that will be the endpoint path, and this is the function that will be triggered when that particular endpoint is called. And in this function we are specifying the dependency for the API key. See this one. So here we are defining the get API key function, and if you remember, this is the get API key function which will validate the API key. So this is how we will be able to add that dependency, and after that, using this event source response and event generator, we are creating a communication stream. This is where our Agno agent is run with the prompt. So the prompt it will get from this particular API function call itself, and the agent will execute this prompt. It will generate the response, and the stream response will be returned to the front end. Finally, we have one more. This is a startup. So this is when the application starts up. This is just to add a log to show that the backend API has started. So this is our main.py of our backend, which will be used to manage the API requests that our front end makes. Now let's look at the Docker file for this particular backend. It is a pretty straightforward Docker file. So here you can see this is the parent image it is using, which is Python. Then we are setting the working directory, which is /app. Then we are copying the requirements.txt file to within the image, and then we are executing the pip install command to install the requirements from that particular requirements.txt file. Then it will copy all the files from the context to that of the working directory, and finally we are exposing the port through which this API backend can be accessed, and we are specifying the CMD. So here this UVCon, this is the application using which you will be able to expose FastAPI. And we will be able to access this particular application using the host, which is localhost via port 8000. Now let's look at the requirements.txt file. So this is the requirements.txt file which will contain the Python libraries that we'll be using for this particular backend application. So these are the libraries. So we have FastAPI, we have UVCon, then we have SOC, Streamlit, Agno, Ollama, and DuckDuckGo search. So these are the libraries that are used by our backend application to ensure that we'll be able to access it via API and to secure that API call. So this is our backend. Next, let's look at the front-end application. So if you open this front-end folder, you will be able to again see three files: the app.py, Dockerfile, and requirements.txt. So these are the three files corresponding to our front-end application. Now let's look at the app.py of our front-end. Here also it starts with importing the libraries. So remember, our front-end will be a Streamlit application from where it will be making the API calls to the backend. So these are the libraries that are required, and this is just setting up the title, session history, and the session date. Now we also add one user input where user will be able to add their prompts, and here this is where we are configuring the API call information. So there are two things that we are configuring here. One is the API key. So we are getting the API from the environment variable that we will be configuring for this front-end application, and we are also configuring the backend URL. And as you can see, the backend URL can be accessed like this. So this backend is the service name within our docker compose.yaml for our backend application. So that is why we will be using this backend host name in here, and we will be able to access it using the port 8000. And we are specifying the endpoint, which is news. Let's look at what happens when the user adds a prompt within the text input, and here this is that particular handler section. Here it is generating the URL with the prompt. See, it is appending the backend URL with the prompt, and it is also configuring the header using the API key. Now it will perform the API call in this particular section, and the response will be streamed and added to the placeholder text. So this is our front-end application. So whenever user sends a prompt, that prompt will be sent to the backend via an API call, and whatever response is generated, it will be sent back to the front end. Now let's look at the Docker file for our front-end application. So it is similar to that of our backend. Only difference is this expose and the entry point and CMD instruction. So here the application will be running Streamlit. So that is why we'll be using Streamlit run, and it will be running on port 8501, and you will be able to access it using localhost. And as you can see here, it is also using the requirements.txt. So let's look at what the requirements.txt is for the front-end application. So here there are three libraries. One is Streamlit, Request, and SOC Client Python. So these are the libraries that are required for the front-end application to work. Now we have two things ready. We have our front-end, which the user will be interacting with, and the backend, which the front-end will be interacting with via API call. During these API calls, the backend will also log the interactions. So next what we have is we have a way using which we will be able to see that log, and that is where this log viewer application will be useful. And like in the other cases, this log viewer application also has got three files: app.py, Dockerfile, and requirements.txt file. Let's look at the log viewer app.py file first. So here we are importing the libraries for our log viewer to work. We are using Streamlit to present the log data, And we are also using existing popular Python libraries like Pandas and plot.ly to perform the plotting operation. Now here we are initializing the log file. So we are saying that the log file will be this one, so that it will be used as the source for the log viewer. Now this is the main function, which is the parse logs function. So this will perform the parsing of the log. Here we are defining the columns and column titles for the data frame that we will be creating, for the graph that we will be creating, for the table that we will be creating. And this is just initializing the variables. Now this is the section where it will open the log file, it will read it, and it will iterate over that log file using regex to identify the log data. And this is how it is generating the log data or populating the data frame. So it is appending the data. So when and where it gets the data, it will be appending to the existing data table. Now this is where it is extracting the relevant data. So only the log data that are related to request and response we want displayed on the graph. So that is what is happening in here. It will extract the relevant information. Now here it is handling the final entry within the log, and it is returning the data. So this data frame will contain the entire data from the log file. Now here is where that parse logs function is called. So this variable will contain the entire log data. So this section is where we will be adding extra items for the Streamlit application, including the data presentation. Here what I did is I created one filter functionality. So in the Streamlit sidebar I added filters. So these are the filters that I have added. There will be one start date and end date filter. There will also be a start time and end time filter. There will also be a text input where user will be able to search to filter, where user will be able to type and filter the log. There is also one reset button. So this reset button will reset the filter applied. So this is what will happen when the reset button is triggered. So this will reinitialize everything so that all the applied filter will be run. So this is where actual filter application will happen. So the filter will be applied to the data direct. Now this section is used to present the raw log as a table. So this is very useful for us to see the logs. And finally we have these three sections to have different representations of our log file. So we have three representations apart from the raw log. One is to see the request frequency over time. Then another one is to see the response length distribution. And final one is to see the common prompt words that are being used. So this is our log viewer application. Now let's look at the Docker file for the log viewer. So this also is similar to our backend and frontend Docker files. Only difference here is the port through which we will be able to access it. So here this is also running a Streamlit application, and we will be able to access them via port 8502 within our localhost machine. And if you look at the requirements.txt file, these are the three libraries that are required for our log viewer to work. So this is our application code. I hope it is clear what are the different items that we have and what each section will be used for. Remember, we now have a front-end application which will be making calls to our backend, which will be making API calls to our backend. This backend will also be adding a log file, and we have another application which will be accessing this particular log file, and we will be able to view the log. So this backend will respond back to the front end with the actual data generated by our Agno agent. So this is our front-end application. So this is running as a Streamlit application. This is our backend application, which will be our Python application, which will be running Agno library. And this is our logviewer application, which is also a Streamlit application. So this is our entire setup. Now let's see how we are combining them together. So that is where our Docker compose.yaml will help. And here, as you can see, there are three services that we are creating. One is the front-end service, then the back-end service, and finally the logviewer service. And in the front-end service, we are specifying the path for the build context so that it will build this particular Docker file from the front-end. We are also specifying the port and the volume, and see this is where we are setting up the environment variable. So we are setting up the API key as the environment variable in here, and we are saying that it depends on the backend service. So Docker Compose will ensure that it creates the backend service first before it creates the front-end service. And when it comes to the backend service, here we are specifying the build context as the backend folder. We are specifying the port and the volumes. So this will include volume for the log storage as well. And here also we are setting up the API keys as the environment variable. Finally, we have the logviewer application. There also we are specifying the build context as the logviewer folder. Then we are specifying the port and the volumes. And here also it will be making use of the logs directory where the backend will be writing the logs to. So this is our Docker Compose application, which when built, it will create three Docker services corresponding to our three services, which will be front-end, backend, and logviewer. Now that we have our application ready, let's go ahead and see how we can build the application. So if you go to the nodes.txt file, you will be able to see the commands which you will be able to build and run the application. So first, let's go ahead and build the application. So once you clone the repository, the first thing that you have to do is to cd into the agno-api folder, because this is the directory which contains our Agno API project files. This is the directory which contains our Docker Compose file as well. So if I see the contents of this directory, you can see our Docker compose.yaml is in this particular directory. So let's build this Docker compose.yaml file. So we'll use the Docker compose up command. So Docker compose up -- build. So this is the command which we'll be using. So this will build all the three services. It may take some time. In my case, it is going faster because I already built this one. So in your case, it will take some time because it will be installing everything that we have specified within the requirements.txt file. So now our application is ready. So there are two applications which will have a front end, and we will be able to use that. Now let's first look at the directory and let's look at the logs folder. And as you can see, it created one new file called api_calls.log. And if you look at that file, you can see it added the startup log, which is backend API started. Now let's see how we'll be able to access this application. So I'll go to my browser and we'll be able to access using localhost :8511. So this is the port for our front-end application. So this is our front-end application which can connect to our backend via API calls. Now whatever query that we make here, it will be sent to the backend and the response will be provided back to us. So let me ask the question, what's the latest AI news? So I'll ask this particular question. So now let me just press enter. So see this, what it is doing is, it is querying the backend. So now the API call is made. Now the backend is generating the response. The Agno agent in the backend is generating the response, and we'll be able to see the response once the generation is complete. See this, Now the generation is complete, and you can see this is the response that is generated by our Agno agent. So how easy it is for our application to access. So no complicated configuration etc. in the front end, everything will be in the backend. Now we'll be able to have our Agno agents running as a service. So you'll be able to create a SaaS application which will serve your Agno agents, and using API your applications will be able to access that particular agent. So that is how convenient this is. Now let me ask another question. So let me ask another query, say what's happening in Times Square. So this is another query, and here also it is making the API call, and now the backend agent is generating the response, and see, this is the response. So this is the response that is generated by the Agno agent, which is the news reporter agent. Now we made two queries, right? So let's look at the log. So first let's look at the log file, and as you can see, the log file populated with the proper request. See this in here we can see the response, and there we can also see the prompt, and we can also see the entire response from the Agno agent. Now this is not that efficient to view the log, so that is why we have our log viewer application. So if you want to access the log viewer application, you can access localhost :8512. So this is the log viewer access point, and this is our log viewer. So this is our filter. I'll come back to that, but here you see this. Here we will be able to see the row log. If you double click on that particular cell, we will be able to see the entire content. This is the entire response. Here we will be able to see the entire prompt, and this is the response for the first prompt, which is what's the latest AI news. Below, if you see, you will be able to see request frequency per 5-minute interval, and also the response length distribution, and finally you will also see the most common words that are used within our prompts. So here this words is used multiple times on both our prompts, so that is why it is 2 and everything else is 1. So this is a very powerful way in which we will be able to process and monitor our log. Now let me just show you the filter feature. So here if you click on this, you will be able to get access to the filter. So you will be able to change the date, start date, end date. Then you can adjust the start time and end time. You can also perform the query. So let me search for AI, and see this in the right side. Immediately the filter will be applied. So now it is only showing the query and data which contains AI inside, and all the sections are updated accordingly. Similarly, if I search for a square, it will only show the query with square in it, or it will only show the log with square in it. Now let's look at the reset option. If you click on the reset filter, it will reset all the filters that were applied. Clear? So that's a wrap. We built a powerful app to interact with Agno agents via API, log every call, and visualize the results. You have learned how to use Streamlit for a slick UI, the Agno framework for agent access, and Plotly for data insights. Want to take it further? Try adding real-time log updates or support for more agent type. Check out the Agno docs and my GitHub repository for more details. And if you enjoyed this, hit that like button, drop a comment with your thoughts, and subscribe for more tutorials. Thank you, and see you in the next tutorial. Bye bye.